Hello, welcome to Tuesday. Well, we started chapter 10 yesterday with the prerequisite skills, and today we're moving on to 10.1. And 10.1 is called the area of a parallelogram. Now, I want to review just a little bit before we go on here. First off, to find the area of a rectangle, we already learned a formula for that. Ready? Begin. Area equals length times width. To find the perimeter of a rectangle, we already have a formula for that. Ready? Begin. Perimeter equals 2 times the length plus 2 times the width. That's the distance around the rectangle. Now, we have also been working on some things about geometry, some very basics. This is called a what? A line. And it reminds me of God because he has no beginning or ending, just like a line. This reminds me of us, but it's called a what? A ray. It has a beginning but no ending. This is a segment. It has a beginning and an ending. It reminds me of animals. This is called a point, and we use capital letters to label those points. These are parallel lines. They never meet. These are intersecting lines. They would meet. These lines meet in a special way. They make square corners, so they're called perpendicular lines. Perpendicular lines. Now, so we've also learned something about angles. Now, we learned that when you have two rays with the same endpoint, it's called an angle. An angle that's less than 90 degrees is called an acute angle, right? An angle of 90 degrees is called what? A right angle. If you have an angle more than 90 degrees, it's called an obtuse angle. If you have an angle exactly, it's 180 degrees. In other words, the rays go opposite directions. It's called a straight angle. These angles have the same measure, so they're congruent angles. Then we also learned something about polygons. Now, a polygon is a closed figure with straight sides. So that's a polygon. If you call, when you have a quadrilateral and it has sides, opposite sides that are parallel, that's called a parallelogram. If you have a quadrilateral and it makes square corners, it's a parallelogram, but it has square corners, it's called a rectangle. What if you have a parallelogram that has all the sides the same measure? It's called a rhombus. What if you have a parallelogram, a quadrilateral, a parallelogram, and it's also a rectangle and it's a rhombus? Then it is a square. Please don't look at me. It's still important that you don't do that. I'm very sensitive about that. Now, if you have a quadrilateral that has only two sides that are parallel, the others aren't, it's called a trapezoid. What do you call this kind of polygon with 5 sides? It is a regular pentagon. Regular pentagon. How about this kind? You can look at a picture here. It has 6 sides, all the same length and same measure of the angles. That would be a regular hexagon. Here is a regular octagon. What do you call this part of a polygon where the sides meet? That's called a vertex. The plural is vertices. What do you call if you join vertices, but it's not one of the sides? It's a diagonal. Now these polygons, these triangles, they're the same shape, but they aren't the same size, so they're called similar figures. How about these 2 triangles? They're the same shape and the same size. What are they? Well, they're congruent triangles. Are they similar? Yes, they are the same shape, but they just aren't the same size, so they can be similar and congruent. All right, so today, we are really getting into a different part of geometry. And we're talking about how do you measure the area of a parallelogram. First off, I want to tell you this. Every parallelogram, and I'm talking about tilted parallelograms, not rectangles here, all right? So every parallelogram can be made into a rectangle. Now, all you have to do with your scissors is to cut along this line here. I drew perpendicular from one of the vertices. I drew it down to this base here. And if I cut with my scissors along there and take this triangle right here, take that triangle, slide it over to here, all right? Slide that triangle over to here on this end. So I'm taking this triangle, I'm cutting it there, and then sliding it over. What I have now is a rectangle, all right? And you can do that with this one. Here, if I cut along this red line here, I get this triangle right here. If I take that and I slide it over to this side, and I paste it over here, like this. Well, now I have a rectangle. Oh, that doesn't look much like a rectangle. Okay, so now I have a rectangle. You can make every parallelogram into a rectangle just by doing that. So there's a relationship between them. All right, so here's what you need to know. First of all, to find the area of a parallelogram, you have to know what the base is. Now the base is just one of the sides. I chose this one down here in the bottom of this parallelogram, so I called that B. That's the base, from here to here. That length is called the base. The height of a parallelogram is when you draw a perpendicular line up to one of the opposite sides. So I'm going to start at the base here, and I draw a perpendicular line. That's what this square corner means. A perpendicular line up to the other side. I just happen to draw it to one of the vertices. All right? You don't have to have it. I could be having it right here, or right here, or right here, but I drew it up to one of the vertices. Okay, so that is called the height of the parallelogram. And the measure of that height is not the same as these. It's not the same. You can see it's less than that. All right, so now you know the base is any one of the sides. The height is one of a perpendicular line drawn from the base up to the opposite side. Okay, so here's the formula. You need to write this maybe down in your note. Remember, we have a little notebook. In order to find the area of a parallelogram, area equals the base times the height. The base times the height. And of course, your answer is going to be in square units because we're talking about area here. Well, let's practice doing that. Let's suppose we have a base of 7 feet and a height of 10 feet in a parallelogram. Well, in the practice today, you're going to write area equals base times height. Let's repeat that right at the beginning. Area equals base times height. All right? You write that, and then you replace B with 7, H with 10. So area equals 7 times 10, equals under equals 70 square feet. Please don't look at me. All right. That's not hard, is it? It's really pretty simple. To find the area of a parallelogram, all you have to do is make sure you know the base and the height, multiply them together, and you have the area, square units. How about this? Let's suppose the base of a parallelogram is 5 meters and the height is 2 meters. Again, you write the formula. Let's say it right at the beginning. Area equals base times height. So area equals 5 times 2, base times height. Area equals 10 square meters. You can't really get any easier than that. That is pretty simple. Okay, what if I give you just a little more complicated problem here? Let's suppose I tell you that the base of some parallelogram, I don't have it drawn up here, the base of some parallelogram is 5 inches longer than the height. And the height, I'm going to tell you, is 10 inches. Can you find the area of that parallelogram? Certainly. I said, first off, area equals base times height. That's the formula. So area equals, well, if the base is 5 inches longer than the height and the height is 10 inches, well, the base must be 15 inches, right? So area equals 15 times 10. That's the height, 10 inches. Area equals 150 square inches. Again, circle your answers and just show that kind of work when you do this. All right, so let's do this. You're going to be asked also to find the unknown measure. Let's suppose that you know that the area is already 45 square centimeters, and you know that the height is 9 centimeters. What's the base? Well, I can do that. Let's write the formula first for the area of a parallelogram. Begin. Area equals base times height. All right? So I replace the A with 45 because the area is 45 square centimeters. Equals, all right? I don't know what the base is, so I continue to use that as my variable, B. But the height, I said, is 9. So something times 9 equals 45. What times 9 equals 45? Well, the B, base, must be 5. And it's 5. Oh, no, Mr. Frazier made a mistake. Centimeters. I've been wrong before. Once I said I was wrong, and I was really right. And so that's what happened here. Hey, I wanted to tell you something. On Friday, all right, here we have Tuesday, Wednesday, Thursday. On Friday, I've asked a special guest come in and teach geometry. So get ready for that on Friday. All right, you're going to be asked to do this also in the practice. Estimating area. All right, so let's suppose I have this lake. And this lake that I have a map of it. And there's the lake. And the map scale is 1 inch to 10 miles. So every inch on the map is 10 miles in the real lake, right? And on the map, I find out that it's 5 inches for the base, for the height, and 12 inches for the base. I draw a little parallelogram around the lake. I wanted to estimate, what is the surface area of that lake? How many, that's a pretty big lake. 5 inches, 12 inches? Well, you're thinking, that's tiny. That's on the map. Remember, we got to use the scale 1 inch to 10 miles. So I'm going to set that up as a ratio. 1 inch to 10 miles equals 5 inches for the height here. And what do you got to do to 1 to get to 5? Well, 1 times 5 is 5. So 10 times 5 gives me 50 miles. So I'm going to find out the height of this is 50 miles here in the real lake. Let's do the same thing for the 12 inches. 1 inch to 10 miles, that is the scale. So I set that up as a ratio. 1 inch to 10 miles equals 12 inches now for the base here. And so 1 times 12 is 12, 10 times 12 is 120. So I have a base of 120 miles. Then I come over here. What's the formula for finding the area of a parallelogram? Begin. Area equals base times height. So I say area equals 50, that was the height, times 120, that's the base, and I get 6,000 square miles. That is a huge lake. Hey, that's the kind of stuff you're going to be looking at in the practice. I really am excited about some of the things we're going to be doing in the next couple of weeks in geometry. Make sure you do have a compass, right? A compass looks something like this, except it's not nearly as big, because eventually you're going to need that compass. See you Wednesday. Bye-bye.